Next 3.23, the decomposition A to R, Ca0 is equal to 1 mole per liter in a batch reactor gives us 75% conversion after 1 hour, and it is complete, that means conversion is complete, Xa is equal to 100% after 2 hours. Find the rate equation. So A gives R, that doesn't give us any information about the kinetics. It is not mentioned about the order, so we have to determine it. So we have two data points here. At time t is equal to t1, t is equal to t2. Xa is equal to Xa1 is equal to 0.75. If Ca0 is 1 mole per liter, Ca1 will be 0.25. So at first data point, that means 75% conversion after 1 hour. So at time t is equal to 1, Ca is 0.25, and that we have denoted as T1 and Ca1. At time t is equal to 2, T2 is equal to 2, conversion is complete, that means 1. So Ca, no Ca will be left, Ca will be 0, that means Ca2 is equal to 0. We use now nth order kinetics integrated form of rate law, which we have derived. So what is the final form? Ca raised to 1 minus n minus Ca0 raised to 1 minus n is equal to this rate constant k bar into bracket n minus 1 into t. So I write two equations for these two cases, 2 points, that means T1 and T2. So for T1, I write Ca is equal to Ca1, T2, Ca is equal to Ca2. So from this equation, if I divide throughout by Ca0 raised to 1 minus n, I have to multiply by Ca0 raised to 1 minus n. So this is taken outside the bracket. And this Ca raised to 1 minus n divided by Ca0 raised to 1 minus n can be written as Ca1 by Ca0 raised to 1 minus n. And this divided by same term, Ca0 raised to 1 minus n is 1. Similarly, for second case, Ca2 by Ca0 raised to 1 minus n, and this is equal to k bar n minus 1 into t2. So we have these 2 points. If I take the ratio of this t2 by t1, this is 2 by 1, 2, and substitute these values. What is Ca2? 0. So this becomes 0, and in the numerator you are left with only minus 1. Ca1 by Ca0. Ca1 is 0.25 and Ca0 is 1. So 0.25 raised to 1 minus n minus 1. For 75% conversion, Ca1 is 0.25. Okay, so this, if you transfer on this side, 0.25 raised to 1 minus n minus 1, and this 2 is transferred on this side, minus 1 by 2 is minus 0.5, or 0.25 raised to 1 minus n is 0.5. So you solve this, you obtain n is equal to 0.5 or 1 by 2. Substitute this value of n in any of these data points. I substitute it in the first one, that is Ca1 and T1. So Ca1 is equal to 0.25, T1 is 1, n is 0.5. So if I substitute n as 0.5, okay, so what I get here, 1 raised to anything is 1, 0.25 raised to 1 minus 0.5, that is 0.5 minus 1, divided by n minus 1. N is 0.5 minus 1 minus 0.5. So value of rate constant I get as 1. So rate law becomes minus Ra is equal to K Ca raised to half. Okay, K is 1. So 1 into Ca raised to half. Rate is expressed in moles per liter per hour, and this half order rate constant, units will be time inverse into concentration raised to 1 minus n. N is half, so 1 minus half is half. So moles raised to half divided by liter raised to half divided by hour. So this is the unit of half order rate constant.